Hello everyone. So today we will be covering section 6.6. So before we get on with the examples, let me talk about a few notes. So recall the simplified form of a radical. So there are the three conditions I mentioned previously. So the only difference in this section is for number 3, I made the note that to remove a radical from the denominator, we use the process called rationalizing the denominator. Right? And then you will see what I mean as we go through the day. One thing I also wanted to talk about was when it says consider any radical expression where the radicand is written as a product of prime factors, and that the radicand has no factor raised to a power greater than or equal to the index. So what does that mean? Since we've been practicing simplifying radicals for a few days now, let me talk to you about another way to simplify a square root. So let me do an example. Let me see. Let's think of the square root of 52. So this is what I thought 13 times 4 was, but it obviously isn't. So what I normally do, or what I told you guys, is you have a list of all the perfect squares, and then you ask yourself, you go from bottom to top and you ask yourself, does this perfect square go into this number nicely? Another way to do this is if you're comfortable making a product of prime factors, this would be a good way for you. Or if the other way kind of confused you a little bit, or maybe after I introduce this, you might like it better. So just giving you guys more tools under your belt. So when I look at 52, right, 52, I notice, so let's say I notice it's even. So I definitely know 2 goes into it. So 2 times what is equal to 52? That is 26. Right? 26 is also even, so this is 2, and then 13. Right? 2 is prime, 13 is prime. So what does that mean? 52 can be rewritten as 2 times 13, right? But if I want them, so product of prime factors, this is it. But what I want to do is I want to just have one factor of each number. So I have the factor 2 and the factor 13. Right? There's 2 2's, so this becomes 2 squared. Right? So let's rewrite it over here. The square root of 52 becomes 2 squared times 13. Right? And this is what the condition 1 means. So first of all, what is our index here? Our index is 2. And it says the radicand has no factor raised to a power greater than or equal to the index. So since there's a square root, we cannot have any factor that has a power of 2 or greater. And as you can see, so what is 13? It's just 1. So as you can see, 2 squared, this power is 2. It is equal to 2. So what does that mean? This can be simplified. Right? And then using this property, so the nth root of x to the n is x. So the square root of 2 squared, so first I'm getting ahead of myself here. Let's use the multiplication property, which I shouldn't make it so big. This becomes 2 squared times the square root of 13. So using this, because there's a 2 here, so what is the square root of 2 squared? That is 2. And then 13, since there's a 1 here, since 1 is less than 2, we know 13 is as simplified as it can get. So this is 2 square root of 13. So let's do another example, just one more, so let it sink in for you guys. Let's find the square root of 48. Right? And I want to simplify this using the perfect square trick. So let's write 48 over here to the side, and let's write our perfect squares. or our prime, just our little factors. So right off the bat, I see 4, and this becomes, what, 12? Yeah. And then 4, it is not prime yet, so I'm going to simplify it to 2 times 2. And then 12 becomes 4 times 2, or 4 times 3, and then 2 and 2. You could have also done 2 and 6, and you've gotten 2 and 3, same thing. Right? So as you can see, so 48, right off the bat, I'm not going to write 2 times 2 times 2 times 2 times 3, right? But I'm going to take all the factors, all the unique factors, which will be 2 and 3, and I'm going to write the power. So for the 2's, I count 1, 2, 3, 4. So it's 2 to the 4th times 3. So let's check our work. What's 2 to the 4th? 2 to the 4th is 16. 16 times 3, that is 48. Right? So this is the prime factorization, this is our product of prime factors for 48. So let's rewrite it over here. We have 2 to the 4th times 3. Right? So now let's use, so when I look at this, this is, again, since there's no index right here, since there's no number showing, our index is 2. So if we have a power that is 2 or greater, then we have to simplify it. Over here is 2 to the 4th, so that definitely needs to be simplified. So 2 to the 4th is over here. And then 3 to the 1st, 1 is less than 2, so 3 is as simplified as it's going to get. So when I look at 2 to the 4th, another way to look at this would be 2 to the 4th times 1, or to the 1/2, right? Because the square root of x is x to the 1/2, square root of 3. So I'm going to use the power of a power rule. So what's 4 times 1/2? That is 2. Right? And then we got to simplify this more. So what's 2 squared is 4. Right? So the square root of 48 can be simplified to 4 square root of 3. And this is the second way. This is another way that you can simplify radicals, right? So now let's get into our examples. And before we get, so one last thing before we get into our examples, let's talk about the division property of radicals. So the division property is pretty much just like the multiplication property. The only difference is that we're dividing instead of multiplying. Now let me read it out. So let A and B represent real numbers such that the nth root of A and nth root of B are both real. So this statement is still true for division. So just like multiplication. Then the nth root of A over B is equal to the nth root of A over the nth root of B, where B is not equal to 0. Why can't B be 0? Because if it's 0, then you'll get a 0 under the denominator, and that's a big no-no, right? So let's start off, finally, with section 1. So section 1, we want to simplify a quotient of square roots, and our first example is to simplify the square root of 57 and the square root of 3. So I'm looking at this, and it's like, how do we simplify this? They both don't have perfect squares or anything, so I can't simplify it in that way. So let's go ahead and do the division property. So they both have an index of 2, and then if I took the square root of 57 and the square root of b, they would both be real numbers. So we are able to use the division property, which becomes 57 over 3. Right? What is 57 divided by 3? 57 divided by 3 is 19. If you don't believe me, let's go off to the side. 3 goes into 5 once. Right? 1 times 3 is 3. Subtract these, you get 2. Bring it down. So 2 is less than 3, so we can bring down to 7. And 3 goes into set 27 9 times. And as you can see, we don't get a remainder. So it's the square root of 19. This is our answer. So if I rewrote, so looking at the simplified form of a radical, looking at all of the conditions, The first one is met because 19, so 19 is a prime number. So this is the prime factor, the product of prime factors. And 19 has a power of 1. 1 is less than 2. So we definitely know that that the first condition holds. The second condition says the radicand does not contain a fraction. So 19 is not a fraction. And then 13, there are no radicals in the denominator of a fraction. So as you can see, we don't even have a denominator to look at. So this is our solution for example 1. Now looking at example 2. Example 2, we want to simplify the square root of 7 and the square root of 63. Right? I'm looking at this, and I actually noticed that, and like I noticed above with the 57 and 3, that they both have a 7 in common. So in order to change it up a little bit, I have to use the division property. So before I do it, I first have to make sure, are the indexes the same? Yes, they're both 2. And then if I took the square root of 7 and square root of 63, I would get a real number. Therefore, I can use the division property, which becomes 7 over 63. Right, now I can divide these both by 7. And when I do that, I get the square root of 1 over 9. Am I done? No. So first, number 1, the radicand has no factor. So I guess we can rewrite this. This would become, because 9 can be rewritten as 3 squared. Right. So first, it doesn't even, it doesn't satisfy the first condition because, and as you can see in the bottom, it oh, excuse me, sorry, oh my goodness, the factor or the power is the exact same as the index. So we know that it can be simplified further. The second one, the radicand, it contains a fraction, both of these, so that's not good. And then the radicals in the denominator, right now, there's none. So right now, it's failing conditions 1 and 2. So let's fix it. In order to fix it, we have to use the division property again. So this becomes the square root of 1 over the square root of 3 squared. Let's bring our work up here. What is the square root of 1? It's 1 because 1 squared is 1. And then the square root of 3 squared, that is 3. I look at this again. Since there is no radicals at all, this is a simplified, and then 1 and 3 can't be simplified anymore or reduced anymore. So this is our solution.